first. Yep. Okay. So welcome all to the session on service-oriented architecture and Oracle SOA Suite 12c. So first of all, let me introduce myself. My name is Ravi Kiran. I'm working as a SOA consultant here in US since last 10 years. So I have very good experience on most of the Fusion stack. It started with Oracle ADF, SOA, BPM, OSB, SOA governance with OER and OSR, literally most of the components on Oracle SOA Suite. I'm currently working as a tech lead for a company as a consultant. I had given trainings earlier, like when I was in India, I had given trainings for about 3 years, and then after that I took a gap for about 2 years now. I'm starting it again. So that's about me. Let's straight away dig into the course. Any questions you have, like, you can stop me at any point and ask me. If just in case if I think that that question is not appropriate at that point of time, maybe I'll let you know, so that at the end of the session, or maybe when the topic is covered, it would be more clearer for you. Okay. So this session is called Building Applications with Oracle Service-Oriented Architecture. So from now onwards, I will call Service-Oriented Architecture as SOA. Okay, we usually call it as SOA, and a vendor-specific tool called Oracle SOA Suite 12c. So what do you expect from this course? You will basically understand the concept of SOA, what SOA is, and obviously every concept has certain principles. So what are those principles, etc. And then you would obviously use those principles to build your composite applications. And you need some tool to build anything, right? You always have the principles, but obviously you cannot do everything. You need a tool to assist you. So that's Oracle SOA Suite. So we build different applications. We go through each and every component. We understand the component, and then we do a practical example on that, so that you are really familiar with the topic. And then we work with various components of Oracle SOA Suite. So obviously SOA gives you many principles, right? So similarly, for realizing each of the principles, or for each of the functionality, I can say Oracle SOA Suite offers different components. Okay, so you will understand about this much later in the course, so maybe after 2 sessions, but anyways, I'm just giving you an overview. So what are the various components you would see? I'm just listing the major components. Okay, I think someone joined. Okay, let's continue the session, so we can have an introduction at the end of the session. Okay, so what are the various components you would be learning? These are, I'm basically listing the major components. One is mediators, adapters. So adapters, there are different kinds of adapters. And then business process execution language, human tasks, business rules, event-driven architecture, business activity monitoring, metadata store, security, user messaging service, etc. So these are the different components that you would be learning. Obviously, all these components doesn't make any sense at this point of time, but I'm just giving you an overview. And the entire course, each of these topics will be, you will be understanding, and then we'll do a practical example right within the session, so that, after the session, you can do it yourself, so that you are more familiar with it. And the entire course, can you please mute yourself if you don't have any questions, because I'm getting some kind of disturbance. Yep, thank you very much. Okay. I just changed my mouse pointer and it's working crazy. Okay. So I have a blog called soatutor.com, which has a number of blogs on SOA and BPM, obviously. You can refer to the blogs, like as and when I go through a topic, there would be an associated blog or blogs on this website. And not only with this website, you can actually do some work whenever you have time, so that your knowledge, you get more and more by reading. And the entire course will be for about 25 hours. We usually do a 1 hour session daily, all weekdays in US. So it would be Monday through Friday, 10 p.m. EST, or it would be Tuesday through Saturday, 7:30 a.m. India time. Usually most of the people would be either from US or India, and depending on the audience of a particular course, the times are little flexible, because if most of the people are from EST, then we would be doing it much earlier. So if it is PST and EST, then I think 10 would be the most appropriate time. So depending on the audience, we can have a final timing after the demo sessions. So that's about the overview of the course. So let's straight away jump into the session. So let's look at the definition of service-oriented architecture. So what it says is SOA is an architectural style of building business applications using loosely coupled services that act as black boxes that can be orchestrated in a particular fashion. Okay, so it basically says it's an architectural style and you use loosely coupled services which are which act as black boxes, so meaning which doesn't have any connectivity with the other ones, I would say, and which can be orchestrated in the sense which can be connected to one another so that you achieve a particular business solution to attain a specific business functionality. Okay, so the definition looks good, but obviously at this point of time, since all of us are really new to service-oriented architecture, it really doesn't make any sense, right? Looking at the definition, okay, we can understand it, but what it really is. So just to understand the concept of SOA in a much detailed way, or maybe in a much sensible way, let's look at what is SOA to a layman. So let's say we are pretty much new to SOA, so obviously we are laymen in terms of SOA. So let's understand the concept of SOA. Okay, so I have, or we'll pick an example, a hypothetical situation obviously, but it is mostly connected to the real world. So we'll take an example and try to understand the concept of SOA. So let's say there is a bank called ABC Banking & Co. Okay, and this bank is pretty old bank. Okay, so it's coming from, say it's established in 1900. Okay, so obviously when it started, obviously every bank offers multiple services, right? So even this bank had different services. So service in the sense, I would say a particular functionality. So opening an account would be one service, or giving a credit card would be one service, and withdrawal would be a one service, credit would be one service. So different functionalities, we are actually calling it as services. Okay, so initially when the bank started, obviously everything is manual, right? Everything is done on papers, and most of the services would talk to each other, right? So if you want to do a withdrawal, you have two accounts in that. So you want to know the account details. Account details is maintained by some other department. So you have to talk to them and get the details. So there are different functionalities and most of them are interconnected to each other. So, okay, when they didn't have computers, or when they didn't have technology, they were doing it on papers, but slowly as the technology evolved and as the computers came into prominence, they had this technology called mainframe. Okay, and mainframe is really good in terms of transactions, correct? So, and even the bank wanted the transactions to be very robust. Like whenever someone does a withdrawal, it has to be updated immediately so that there is no fraud, so that he does not go again and then withdraw the same amount before updating. So they want the transactions to be real fast and it has to be robust. So when they heard of this mainframe technology, they're very satisfied. The bank, or the business thought that, okay, this is a good time to actually do the services, to implement the services as mainframe components. So let's assume this component 5 and component 6, or say service 5 and service 6 are transactional services. Okay, so when they really got the technology, so they formed an IT department and they created two services. Okay, so basically they took out the manual thing there and they automated using the mainframe technology. Okay, but obviously these two services, since they are of the same bank, they have to talk to each other, right? Though they are doing different functionalities, there is a possibility that they have to talk to each other. And since both are on the same technology, yes, I can talk to each other, right? I mean seamlessly, in the sense, just like if there are two Java classes, you just instantiate the class and then you call the operation, right? In the same way, mainframe would have its own protocol. So using that, they were talking to each other. And these two services, 1 and 2, these two do not work in silos, obviously. I mean, there are other 4 manual services, but there would be situations where these the service 1 and service 2, or maybe I would call it as service 5 and 6. That's better. Service 5 and service 6 need to talk to the other services. I gave you the example, right? When there is a withdrawal, it needs to talk to the get account service, which is service 2, which is manual right now. So there is, in this situation, like, they cannot work in silos. So obviously the communication also happens between the manual services and the automated services. Okay, so this is the situation when they had the technology. And obviously initially when mainframe is not so robust, or say it is not evolved, I mean implementing it a service in mainframe is really costly, right? I mean, we are talking about 70s, so it's very costly. Software was very costly, even the resources were very costly. So business really thought that if it is really required, let's do them. And obviously mainframe wouldn't satisfy each and every functionality. It doesn't have a good layout, so there is no point in doing a UI using the mainframe. So they thought, okay, let's put it as manual services. And slowly, as the company grew, the number of customers also have increased. Okay, so let's assume this service 1 is taking care of opening a bank account. Okay, so for any customer, that is the first step, right? He has to open the bank account for doing anything, or taking a loan, or crediting money, whatever it is. So as the customer base increased, this department is filled with more and more applications, and it couldn't process all the applications faster. So obviously this is becoming kind of a bottleneck to all the further services. Okay, but this service is very critical because obviously consumers are very critical, right? You cannot just ask the consumer to wait for 2 days just to open an account. So the business and the IT department are actually waiting for a good technology to come up. And when they have seen a technology like Java, which really supports very good layouts and all, using JSPs and all, so they thought that, okay, since this is becoming a bottleneck using the manual service, let's make it an automated service. So they have made this service 1 as a Java component. So they thought like, okay, now it's the time for this service to be implemented as a software component. And then they have implemented service 3 using Java. It's not only Java, it could be any other technology for that matter. I'm just giving an example like Java. Okay, now, okay, we have service 3 as Java, and obviously this service 3 cannot work in silos, right? I mean, it needs to talk to the other services at some point. So, but does this communication happen seamlessly? Like if it wants to talk to, say, service 1 at some point, or maybe the other way around, if service 1 wants to talk to service 3, can it happen seamlessly? If you observe, the technologies are completely different. So obviously, I mean, when the technologies are different, they follow different protocols, right? So I can say they talk 2 different languages. One talks German and one talks French. So obviously the communication cannot be seamless. I mean, when a French guy is talking, the German couldn't understand, right? The same thing happens. So is it compatible? Obviously it's not compatible. So what do we do? Usually when there are 2 people talking 2 different languages, what is the solution? You either learn the new language, which is obviously a little difficult. Instead, you can get a translator, right? You can have a translator who knows both the languages. Okay, so the French guy talks to the translator and the translator translates it to German and vice versa. So the same thing happens even here. You would need a translator. In other words, in technical words, I would say you would need a communication layer which takes care of all the protocol transformations. Okay, so let's represent the communication layer as a box here. So basically this communication layer would be another software component which basically transforms the protocols between Java and mainframe. So whenever service 3 wants to talk to service 1, what happens is service 3 creates a request, and then the intercommunication layer or the transformation layer basically converts it into a protocol that is understandable by mainframe, and then it sends it over to the service 1, and then service 1 replies back with a response to the communication layer, and then the communication layer translates it into Java specific thing and it sends back. Okay, so this is one way communication from Java to mainframe. Similarly, service 1 also have to talk to service 3, right? So how it happens? So service 1, which talks mainframe, will first send it to the intercommunication layer, and the intercommunication layer will translate it to the Java format, and then it sends the request. Obviously it bypasses this one, and then Java responds back to the intercommunication layer. It translates into the mainframe technology, and then it goes through. So that is how the communication happens. Let me erase everything. I'm just trying to erase everything. Just a moment. Why is it not happening? Okay, there seems to be some problem with the highlighter, but whatever. Okay. So the same way, when service 2 wants to talk to service 3, there should be another intercommunication layer. Please pardon me for just a moment. For some reason. Okay, now it's working. Okay. So even service 2 communication also happens in the same way. So all the inbound and outbound interactions are done through the communication layer. So in this case, we have the business logic as software components, either written in mainframe or Java. And apart from that, we also have the intercommunication layer, which is also a software component, okay, which basically translates the protocols. Okay, now let's say going forward, even service 4 is implemented, and service 4, they thought for some reason they thought .NET would be a right technology, or maybe they have outsourced this to some company which is really good in .NET and they have implemented it in .NET. So for some reason, let's assume that service 4 is implemented in .NET. So obviously even now, since the protocols are different, you need an intercommunication layer to do it. So if you look at the interaction points here, so each and every interaction point would require a communication layer unless the technology is same. Okay, now this is happening and we have few manual services, and suddenly there were very new requirements, like the business has grown very drastically and they have come up with new acquisitions. Okay, so as the number of services increase, see, if you see, as more and more services take IT form, more intercommunication layers and more interactions. That is obvious, right? You have more intercommunication points. So if there are 4 services, it would be 4p2. If you know permutations, it would be 4p2. So totally it would be 6 different intercommunication points. So you need 6 different intercommunication layers for each component. Now let's assume this company has grown too much. So let's say it has acquired new companies, and then let's say it has come up with new functionalities like reward points. Okay, so reward points, which was not there till now, is a new is some new functionality. So they want it to be as a software component, or they have acquired new companies. So obviously when you acquire a company, the acquired company would have some software components, right? You still want to use it, but those would be in some other technology. Irrespective of whatever technology it is in, you still have to use those services, right? You cannot just stop all the existing services when you acquire some company, and then you want to implement all the manual services, like you want to uh, just get rid of all the manual work and automate everything. So when you take care of all these things, you would come up with an architecture something like this. Okay, so in this case, if you see, this is just a hypothetical situation wherein there are 6 different services that we had, and 2 services have come from acquisitions, or those are new functionalities, and obviously it would be possible that each would be in a different technology. So there are some mainframe components, there are some EBS services, there is a SAP module, SAP module, and through the acquisition we have got 2 services here which are completely written in their own native technology. There was a company, there was a startup which has come up with its own API, but unfortunately we have acquired it, so we need to integrate that service, but it's in a native technology. So all these guys are talking different languages, so obviously you need a intercommunication layer. So our overall architecture at this point of time is something like this. Okay, so, and let's say a new service comes, then you would have the service, you would have the intercommunication layer, and you would have all these interaction points. If you see here, it's real messy, right? So let's see what are the different problems we have with this architecture. So what is the basic concept that we are following here? We're not following anything. As and when a new service comes, we are just doing it, writing the intercommunication layer since we want to talk to the other components, and then we are doing a point-to-point connections. So what is the problem with this kind of architecture? So the number one problem that you see here is, look at this, it's real messy, right? So you have too many number of connections. Why is that? Because you're doing a point-to-point connection. Okay, now what is the problem if you do a point-to-point connection? Let's assume this service 8 is hosted in this location. Let's assume it is 10.20.30.44. Okay, it's an IP address. Okay, well and good. All the 7 components are talking to this. Now let's say this is on server 1, and for some reason server 1 is decommissioned and it is moved to server 2, which has a different IP obviously. Let's say it is 10.20.40.50. Okay, so now what happens? Now this service has changed because of various reasons, okay, or at least the location has changed. The service functionality did not change, but the location has changed. But what is the problem? Now this service 1, since it is a point-to-point, how it sends the request? It has a request which has 2 things. Every request has 2 things, right? One is the metadata and the other one is the actual payload, correct? So this metadata will basically have the address of service 8. Let's say it has 10.20. something hard-coded. So earlier it was going through the intercommunication layer straight to this service and getting back. Okay. Now since the address of service 8 has changed, service 1 has to change its request to have the new address. Okay. So that's the problem with point-to-point. If the service provider changes, all the service consumers have to change. Now in this case, it's not only service 1, we have 7 services talking to service 8. So all the 7 services have to change. Now imagine there are 100 services. Obviously in a big enterprise there would be hundreds of services, right? So if you have a point-to-point, That is the major problem. Okay, so the first problem that you have here is point to point. Okay, and what is the second issue that you have here? The second issue is, look at the number of connections. Like, there are too many connections, right? Actually it is NP2 connections, where N is the number of components. Okay, as N increases, it increases almost exponentially, if not exponentially. And what is the third, and I would say that is the most important problem, is writing the intercommunication layer. Now, let's say you have a logic. Now, there is no other go. You have to write the logic in some technology. Okay. So business wants it. Obviously, the IT department does it. And because you are following this architecture, okay, you have to deal with the intercommunication layer. There is no other go. If there is no intercommunication layer, there is no way that service 4 can talk to service 6 in SAP. Okay. Now, writing the intercommunication layer is a real headache, because you just think of a real world scenario. If you need a translator between German and French, this guy has to know both the languages, right? Now that the speaking person and the listening person knows only one language, the translator has to know both the languages, or basically he has to know how to convert. Okay, so the same applies here. The intercommunication layer deals with the protocol conversions. So obviously different technologies have different protocols. So converting them is a real pain point, and it is usually done in very low languages like C or C++. Okay, so obviously doing intercommunication layer takes a lot of time, and it takes a lot of resources, which is extra as per the business. And obviously C++ resources are very costly, right? So even the expenditure is also very high. So basically intercommunication layer is another big problem that you have. Okay, and what is another big problem because of this? Because of the intercommunications layer here, you are having a major business IT gap. Okay, now what is a business IT gap? Every company would have business, right? So business is the main part, what they do. So business would sponsor a project, an IT project, saying we need so and so functionality, and the IT department would implement the functionality, right? Now business wants, say, reward points. So IT department does the reward points coding, and apart from that, it also has to write the intercommunication layer, right? So business is expecting something at some point of time, but IT could not deliver it so fast because it has to deal with some other things, which business really don't care. Business doesn't care about the intercommunication layer, right? All it cares about is the business. So there is a small gap that is coming between the business and the IT. What business really wants is on time, on budget, but those two are not happening because of this architecture. So let's see how it is. So what are the limitations to this approach? Whatever we talked till now, uh, it's on the slide. So more time is taken to develop the intercommunication layer rather than implementing the actual business logic, so which comes as a business IT gap. When there is a business IT gap, obviously business is a division which funds your IT, right? So when there is a gap, obviously it's not good for the whole enterprise. And then there is a direct interaction with the peer components, which makes maintenance a nightmare. So we have seen, if service 8 changes its location, you have to change the request of each and every service, which is like a maintenance. You don't want to do it, but there is no other go. You have to do. And then look at the number of connections. Actually, this equation is wrong. It is NP2. Okay. So basically, there are too many connections, which is obviously a maintenance issue. And then there is a tight coupling. So because of the tight coupling, a change in one service affects all the other services. So let's suppose this is taking currency in terms of dollars. Okay. So for some reason, it has changed its currency into euros. Okay. So all the interacting applications has to change their request. or in other words has to change their code because of the tightly coupled nature. So obviously all this would become very expensive, and even a simple extension to the current infrastructure requires too many changes. For example, I want to introduce a new functionality. Just writing the code itself does not cater your purpose. You have to write the intercommunication layer, you have to deal with all the connections, etc. So how would you cope up with all these things? Since you are not following any specific guidelines, you're just doing as and when it is coming. As a company is growing, it is becoming a real big headache, right? So we have to come up with some solution. So let's see what is the solution. So the first thing that you could think of is, since the major problem here is the intercommunication layer, you can think of a solution wherein all the components are redone in some latest technology. Let's say there is a technology called X. I would not mention any technology. There would be some technology X which is very good, okay, which is the most latest and which is really robust. Okay, so if I re-implement all these modules in this language X, then I don't need an intercommunication layer, right? Now that is a good solution, but obviously will business agree? See, business is comfortable with all the existing services, right? What it is asking is if there is any new functionality or if there is any enhancement to the existing one, you just do it. Why will the business agree and it funds you for just re-implementing already existing stuff? It doesn't want to do. And moreover, if you talk about the services 1 and 2 here, they're coming since like 40-50 years. Business would never dare to even touch them, right? That is the whole reason why even most of the things are still on mainframes when there are real good technologies in the market. Like they don't want to touch it. I agree that mainframe is a very good technology, but still there are other technologies also, but business wouldn't like to touch it because it's really robust and it forms a core of their business. So obviously re-implementing in some new technology is not a good idea. And for example, now okay, technology X is good. Say after 10 years, there might be a new technology Y, or your company might acquire another company which uses technology Z. So even then you will have this all the components in X and you have the new component on Z. So again you fall into the same issue, right? So obviously re-implementing is not at all a good solution. So it says re-implementing the existing ones, no way. Business would not agree it because they form the core of their business and they don't want to touch it, or it is basically unnecessary, right? It's already there. Why you want to re-implement the wheel again? So then what is the solution? So if this is not the solution, what is the solution? Okay, so let's deal with each and every problem one by one. Okay, so we are just talking about the concepts. We are not talking about how we are going to achieve that because that is the later part. But right now we are just talking in terms of layman, right? So let me clear off everything, try to do it. It's not happening. So let's not do it. Okay, so let's deal with all the problems one by one. What is our main first problem? The number of connections, right? So instead of having too many interacting points, we can have an architecture something like this. Have a common middle layer. Okay, so something like this. If you see, there is a common middle layer and this communication channel takes or does the headache of that rerouting everything. Okay, so let's assume this communication channel, you can actually compare it to a postal department. Okay, so if you want to write a letter to your friend, you just write the address on the letter and then you put it in the post box, right? Now how the letter goes, it goes via this state or it goes via that address, you really don't care. It's a headache of the postal department, but it gets delivered to your friend. Okay, so the same concept applies here. You have a communication layer. Now how this is implemented is a different story. We'll talk about it later, but we're talking about the concepts right now. So have a common communication layer which deals with all the routing stuff. Okay, So the whole purpose of your duty is just to give the request to it and just say go to service 8. So in some way it reroutes to service 8 and then it gives you back the response. Okay, so that's one solution. Okay, so the advantage of this is, look at the number of points. So from NP2 you are actually coming, NP2 is the number of connections earlier, now we are coming to n. Let's say this n or number of components you have is 10, so you will have 45 connections drilled down to 10 connections, which is a real good thing, right? You have less connections to maintain. Okay, now this has reduced the number of connections, but did it reduce the tightly coupled nature? Now let's say my request is this. Okay, it has a header, so header says go to service 8. I'm just, for easiness sake, I'm giving 8. It would be the IP address, but let's say it has 8 and all the payload. Okay, now let's say this service 8 has moved from one location to another. So you still have the problem, right? So in order to cope up with that problem, we have another solution. Let's assume that we have a service registry. Now guys from US, you can actually think of this situation as if you are aware of USPS change of address. Okay, so how it works, you're in, say you're in Florida, okay, and you move to say Michigan. Okay, so what you do is you log into USPS. Okay, you pay a certain amount obviously, but you log into USPS and then say you give your old address and you give your new address, and automatically all the letters to your old address are routed to your new address, right? So the same concept here. You have a service registry which maintains all the addresses. Okay, so in your request you use a logical name instead of a physical name. Okay, so what is the advantage? Now let's say the service registry, how it works is, let's say there is service 8, there will be a service name and then there would be an address. I'm just giving you a simple thing. It wouldn't be like this, but I'm just telling you. So it would be something like this. So service name and then service address, say 10.20.30.40. Okay, so in my request I would just use a logical name. Okay, so I will say service 8. So what happens is this request goes to the communication channel, and now the communication channel takes this logical name from the metadata, it goes into the registry, gets the physical location, and it delivers to that physical location, and then it responds back. Okay, now let's assume service 8 has moved from point A to point B. So the only thing that you have to do now is you update the service registry. So instead of this address, I would say I would give the new address 10.40.50.60, whatever it is. Okay, so will my request change? No, my request will still use the same logical name. It goes to the communication channel will go to the registry. Now it gets a new address and then it reroutes. Okay, so the same concept, just like Yellow Pages. You have a restaurant and its phone number. If the restaurant has moved, the restaurant guy will update the Yellow Pages, right? Now, how would you go to the restaurant right now? You still open the Yellow Pages, but you find the new number. Obviously, if it is a new edition, you find the new number, right? So the same concept here. Now, what is the advantage of this? The advantage of this is a change in one service is not affecting a change, or it is not creating a change in the other ones, right? The way I'm doing my request is still the same, though the service moves. Okay, so basically at the tightly coupled nature has become now loosely coupled. Okay, so in other words, I can say that a change in service 8 is on, service 1 is not aware of change in service 8. So basically those two are like black boxes. Okay, so one doesn't know about the other, but they are still talking to each other. Okay, so we solved the intercommunication, number of connections problem. We solved the tightly coupled nature, but we are left with one of the major things, which is the intercommunication layer, because this is the one which is taking time and money, right? So how do we deal with this? Okay, so what we do is, the whole point of intercommunication layer is because each guy is talking a different language, right? Or each guy is talking a different protocol. Okay, so the concept is, in some way you make each and every component talk the same language. Okay, now how you can relate this is, there are different European countries, right? Let's say, or for a simple example, there is a German guy and there is a French guy and there is a Polish guy. Okay, there are three people. Okay, how do they communicate? One way is to have a translator. Okay, that's out of question now, because we cannot write all the intercommunication code. So the other way is, let each and every component learn only one language. Let each and every guy speak in English. Okay, so the German guy learns English and talks English. Okay, similarly the Polish guy will speak in English. So if everyone is talking English, which is a universally accepted language, at least at this point of time, just giving a hypothetical example, then there is no problem, right? So the same applies here. So you, in some way, you make each and every component follow the same protocol. Okay, so how you do it? Something like this. You wrap the code, or basically you write your own intercommunication layer, okay, so that it speaks only one language. Okay, and what is the universally accepted language in terms of computers? It's XML. Okay, now let's not dig much into XML right now, but basically the concept is, make each and everything talk a similar language. So in this case, if you look at service 5, or if you look at each and every service, the wrapper code just deals with technology X to XML. Similarly, technology SAP to XML. So the wrapper code just deals with one translation. Whereas earlier, if you look at our earlier example, okay, in this intercommunication layer, where is my pen? Okay, though it is a single box, from .NET to Java it would have one conversion. From .NET to SAP it would have another one. From .NET to EBS it would have another one. .NET to native it would have another one. So earlier, though it is a simple box, it would deal with different transformations, right? But whereas right now, you need not learn all the languages, you just learn English. Okay, simple concept. So this wrapper code just converts into one it just does single translation, that is from whatever technology to XML, or I would say universally accepted language. Okay, so that way you're not wasting too much time. Obviously you're wasting time on top of your business logic, but it's a simple one-way translation. Okay, so this way, if service 2 wants to talk to service 11, which are different technologies by the way, service 2 will change its code to XML. It goes through the intercommunication layer with the help of service registry. It routes to service 7. Okay, so this XML, the wrapper code converts it to native, and then response back XML, and then it gets an XML response back, it gets the mainframe code. Okay, so this is how the communication happens. So this way you have dealt with the intercommunication problem. Instead of having so many transformation layers, you have only one layer. Obviously you have to do it because there are different technologies, right? But it is a simple way to do it because you are dealing with only one transformation. Okay, so what is the solution? The solution is basically having a common layer, having a service registry, wrap the code so that it speaks a universally accepted language. Okay, so following this approach would give us the following advantages. What are the advantages? We have greater business agility, meaning if business comes up with a new functionality, the only thing that you do is, where is my pen? Okay, you just write the business logic and then you wrap the code so that it speaks XML. Okay, so just one translation layer, that's all. And then you just connect it to the intercommunication layer, register it in the registry, you're done. Okay, it's so simple. So you have greater business agility. A new component in the enterprise would have the implementation so easy. So obviously the time taken is much lesser. The cost, it is really cost effective. So you have a minimum IT business gap. A change in the service provider does not require a change in the service consumers. We have seen, right? A change in service rate would just, I mean, it is the other services doesn't even care. Okay, so service rate just updates the registry and you're done. So obviously it's lower cost and better return on investment. Why I'm talking about investment is SOA is, I mean, the SOA tools are really expensive. So obviously there is an investment, but you get return on investment as and when you get your new services. So, okay, so Tommy asks, so it is more of an ESB engine. Let me look at the question. Okay, he says it is more of an ESB engine, not an EAI one. Okay, so the communication layer, if you see here, okay, and the service registry, you're talking about something called routing, right? And some transformation. So these two concepts come into the enterprise service bus, but SOA does much beyond this. Okay, yeah, much beyond routing and transformations, etc. So it has many different components, like wrapping the code so that it talks the same language. It does it. Okay, and then you have the business orchestration. Let's say you have a complex business service where you need some 10 different services to be connected to each other. Okay, so it gives you, and then if you have human tasks or if you want human interaction in between, simple example would be your expense reports. You file an expense report and your manager has to approve it. So all these things SOA provides. So SOA provides much more than an ESB. Okay, you cannot say it is exactly an ESB. ESB does its specific purpose, SOA does its specific purpose. You get into, I mean, you'll have a much better understanding when you really dig into the real topics. At the first glance, you would think like, okay, ESB is a part of SOA. No, it's not part. ESB has its own purpose. SOA has its own purpose, but there is a little common between both things when it comes to routing and transformations. Okay, so that is the solution. Okay, we spoke about 3 different things. Let me just reiterate. So having a common middle layer, having a service registry, wrapping the code so that it talks the same language. So all these simple things, when they are put in a more formal way, it is nothing but service oriented architecture. Okay, so it's not some very big thing. So it tells you some simple concepts you have to know. So everyone knows about these concepts. Only thing is we don't apply them. When you really apply them, it becomes service oriented architecture. Okay, so what is SOA? SOA is an architectural style for building business applications using pluggable components. If you see there, each and every service is like a pluggable component, right? Like if you don't want service aid, just remove it and then you remove it from the service registry. Okay, so whenever some other service calls service aid, I mean the infrastructure will tell you that there is no service aid, so it gives you an error message that way. Okay, so it's all pluggable, so easy to plug in. And SOA is a standards-based approach of developing and integrating heterogeneous systems. So all the systems here are different systems, right? So they are heterogeneous systems, and SOA gives you a standards-based approach so that you have all the benefits of extensibility in the future. SOA aims at extensibility, agility, return on investment, and cost effectiveness. We have seen all these. So SOA aims at a greater alignment between business and IT. Okay, that is the whole purpose, right? So if business wants a functionality, IT can deliver it on time because it is following some new standards. I mean, it is following a set of standards, and using that, it can actually deliver it on time. Okay, and even the maintenance is really easy here. So obviously the costs involved are very less. So business is happy, IT is happy. It helps business respond more quickly and cost effectively to the changing market conditions. Okay, so if your competitor has come up with a new functionality, so business wants a new thing, so it tells the IT department and it can provide it so quickly, right? So that's the advantage of using SOA. what are the advantages? We have seen all the advantages, and I mean we spoke about them in layman terms. So let's see. Advantages are greater business IT alignment, adaptability to various rapidly changing business factors. Okay, let's say now, I mean, a very simple example would be now UK has come out of the EU, right? So there are so many things. I mean, let's say there is a business which is common across countries. Okay, now they have to like separate them, and they have only 2 years. Let's say it has only 2 months, for example. Okay, you can do it so easy if you're following SOA. If you're doing the native approach, it would be real help. Standard based approach, so it's very compatible. Easier and quicker development and maintenance, and the turnaround time, like the requirement to delivery, would be very fast, and better return on investment, and better monitoring approaches for your business. So I haven't taken you through the monitoring because my example wouldn't fit this, but obviously there would be monitoring facilities provided by the tool. Okay, so you can really know how many requests are going through. You can really know how many customers have opened new accounts, or how many have gone out from the bank. So you will know everything. SOA even provides this monitoring capabilities. So what is SOA really about? Now, SOA is not a technology, or it's not a platform. It's not a product. It's not a specification. So let's deal with each and everything. It's not a technology. It doesn't tell you that to use, I mean, it is not a technology like Java, .NET, wherein you have an API. Okay, so it does not have a specification. Like, you don't have an API which you want to use to build SOA applications. It is not a platform on which you build applications. It is not a product. SOA is really generic. Okay, so it just gives you the principles. It tells you follow so and so principles. Just, I mean, you can compare it to what do you call, design pattern. Okay, what does a design pattern tell you? It just tells you that if you follow so and so rules, your application is more robust. Okay, it doesn't tell you use .NET or use Java, right? The same design pattern is applicable to both Java and .NET. So it's not a technology. Same way, even SOA doesn't tell you to use any technology, or it doesn't give you a platform. Okay, then what is it? It is just a set of standards. Okay, so I will highlight this one. It is just a set of standards using which you can build your business applications in a more effective manner. Okay, and I would like to highlight this business. Okay, so if it is just a simple web application wherein you have an UI, okay, and then you have a database, and then you get a response back. If this is your whole business requirement, don't ever come to SOA. Okay, because SOA involves huge costs. Now this is a simple thing. If it involves complicated business logic, only then you think of SOA. Obviously every big enterprise has very complicated business logic, right? By complicated business logic, I wouldn't say it's complex calculations. I would say different flows or different processes. Okay, you will understand more when you go further. I have another question. Okay, so Tommy asked me, is it same as Fusion? Okay, I will tell you about the Fusion at the end of the class. I mean, it doesn't fit right now. So what is Fusion and what is this one? I'll tell you at the end of the class. Okay. So till now, any questions? Am I fast? Am I slow? Anything? Is my voice clear? Okay.
Ravi, looks good.
Okay, thank you. So yeah, any questions you can ask at any point, or maybe at the end of this session. Okay, so I would say it is just a set of standards. If it is just a standard, how do we realize it? Now, I mean, since you are really aware of all the design patterns, I'm just giving you that example. Okay, so let's say, I don't remember the design pattern name. Let's say, give me one design pattern name. Anything? Okay, let's say a design pattern. Okay, it tells you to do, let's say it asks you to keep all the different logic modularized, okay, or implement different functionalities in different classes. Okay, now it doesn't tell you do it in Java, or it doesn't tell you do it in .NET, or it doesn't tell you how to do it. Okay, you just take that statement and you use the statement and do it in your own language. So you can implement it in Java, or you can implement it in any other technology. So even here, SOA doesn't tell you, or SOA doesn't ask you to do in any specific technology. You can write your own stuff, or you can use some tool which is available in the market, or you can use an open source platform. Anything you do, but you basically follow those standards. That is what SOA tells you. So, but just to follow the standard, like, see, what are the standards? This is the one, right? So I cannot do the communication layer, obviously. I cannot write this, right? No, I cannot implement the whole postal department, correct? Or I cannot write the software for the service registry, or I cannot write this code. I mean, I can still write it, but it is all, I mean, it's not my business. My business is to write the business logic. That's what I am for, right? So all these extra things, so what tells you to do it, but how you achieve? If you really have time and patience, you do it. Obviously, no one does it. Then how do you realize it? You realize it using tools. Okay, so you have certain tools using which you can achieve these principles. Okay, so when you do an application, when you write an application using such tool, it automatically adheres to all the SOA principles. Now, one such tool is called Oracle SOA Suite 12c. So SOA and Oracle SOA Suite is not same. SOA tells you the principles, and Oracle SOA Suite will assist you in building your application that adheres to all the SOA principles. So I do a simple application in SOA Suite. It automatically adheres to the SOA standards. Now, how it adheres to SOA standards, we will look into that tomorrow in the second session. But basically, that is what SOA Suite is. It is just a tool. Okay, so it is a product by Oracle which can be used to build your SOA based applications. Okay, so this course is all about understanding SOA principles. So in the first two sessions we would understand the SOA principles. Obviously today we saw what are those in a very layman terms. Tomorrow we'll talk into more technical stuff. Okay, and then we will look into the actual tool. This is what you do in the projects. Okay, this is what you use to realize or to implement your solutions in the enterprise. Oracle SOA Suite 12c, what it is. Oracle SOA Suite 12c is a part of Fusion middleware stack of software components. Okay, now we have come to this one called Fusion. Okay, now Fusion is not some technology or something like that. Oracle has bundled all the related technologies into something called Fusion. Okay, so this Fusion have different things like the UI technologies like ADF, okay, and the middleware technologies. So most of these are middleware, okay, and the orchestration layer like SOA, OSB, and then governance tools like OSR or Oracle Service Registry, Oracle Enterprise Repository, and BA tools like Oracle BI. So all these tools, which are mainly middleware, are bundled and they are called Fusion middleware. Okay, so it has coined a generic word to all the technologies. Okay, so when you hear Fusion, it is not something different. Okay, now you would have heard about something called Fusion applications. Fusion application is something like application. You would have heard of SAP, right, or Oracle EBS, or PeopleSoft, or PRMS. So all these are ERP tools, right, or ERP applications. So even Fusion apps is also an application. Fusion application is basically the next generation to EBS, and it is implemented using the Fusion stack. So it's called Fusion applications. It has nothing to do with SOA. Okay, so it is a part of Fusion middleware stack of software components. It is a next generation platform to build all the SOA applications. It gives many proprietary features apart from the standard specifications. Let's stop till here. Where is it? Okay. Now we spoke about different principles of SOA, right? Now someone has to coin those principles, right? So there is a team called Oasis. Oasis is an open source organization which takes care of the SOA stuff. Okay, just like w3.org, there is a team called Oasis which basically takes care of all the things. So they define what is SOA, they define what are the principles you want. Okay, so that is not a small organization. Like you have everyone, you have all the research done to tell you what to do. Okay, so these guys gives you so many principles, and on top of this principle, let's say these guys gives you like 8 principles or 8, they tell you like if you have all these tools, then you would have your SOA applications. Oracle does its own research and they have come up with even more things, and they have bundled together into Oracle SOA suite. So that's what it says. It gives you many proprietary features like the user messaging services. Like using Oracle SOA, you can send an SMS, or you can do a fax, or you can place a call, etc. All these are not defined by Oasis. But since they are mostly used in your regular day-to-day business, SOA has provided, or Oracle SOA suite has provided you those features. So it has been provided many proprietary features which we will learn as part of the course, which helps developers build applications with many more features and not deviating from the SOA standards. Obviously, you do whatever crap you want on Oracle SOA Suite 12c, it adheres to SOA standards. Okay, because the tool is implemented that way. How it adheres, we'll see tomorrow. Now it is the next generation platform on which Oracle Fusion applications. I mentioned this point specifically because Fusion apps is something really big, and Oracle has invested so much, which is the next generation ERP from Oracle is based on. Okay, so before checking at the underlying technologies, any questions till now? Or at least if not, I mean, you would have so many questions right now, like what is a mediator, what is adapter, or how do you do that routing logic, etc. Now all those are implementation stuff, we'll deal with it later, but at a concept wise or at a principle wise, if you have any questions, just let me know or we'll continue. Like we just have one more slide, that's all. Okay, I take it as no questions, and then let's see what are the underlying technologies in service-oriented architecture. In other words, I would say these are kind of prerequisites. Okay, it is good if you know all these, because in SOA or using the tool, you wouldn't handwrite the code much. Like you wouldn't write the code just like in a Java class you would type all the code, right? So you wouldn't do all that stuff. Obviously you code or you implement things using the tool, but basically it's more of a drag and drop. Okay, unless there is some specific requirement like the transformations or some things that tool doesn't provide you, you obviously write with your own hands, but basically it's more of drag and drop. So even if you don't know this, it is good, but it's always good if you know the underlying technologies, right? So what are the underlying technologies that SOA uses? First and foremost thing is XML. Okay, I told you, right, if everyone speaks English, there is no problem. Same thing. So XML is considered a universal standard for communication now. So all the interaction happens with XML. So you just know XML and you're good. And what is the other one? Schemas. Okay, now what is schema? Schema tells you the format of the XML. Okay, so a create account request would have the first name, last name, address, and then say account number, or let's say account is the request name, account number. So it would have these fields, right? Whereas Give me another example. Okay, a document would have doc name, doc content in binary, let's say, and doc extension. Okay. Now, if you look at these two are requests in two different services. A document service would have this request, account service would have this request. Okay. If you look at this, it has 4 fields, it has 3 fields or 3 elements. Okay, even the types are different. Okay, so when you are talking to an account service, how would you know you want to use this format? That is what XML schema tells you. Okay, for a document service, it clearly tells you like you need to have 3 elements, and first element has to be string, second element is binary, third element is string. So basically XML schema will tell you the structure of the XML. Okay, so the content is XML and schema tells you the structure. And then the third one is web services. Now what made you each and every component pluggable in our previous diagram, the final diagram, is nothing but the web service. So when each and every service work as a web service, you can talk to whatever component you want. Okay, you just place the SOAP request, you're done, you get the response. Okay, you need not think about any other transformation. So web services is one underlying technology. And obviously when you have web services, the format in which two web services talk is SOAP, or Simple Object Access Protocol. UDDI is the Universal Description, Discovery and Integration. We have seen the service registry, right? So it is basically the concept of UDDI. Okay. And then WSDL. WSDL basically tells you the whole format of the web service. Okay. So these are the different underlying technologies, and I would say XML and schema and definitions for web services and SOAP, WSDL. So I would say these 5 as kind of prerequisites. Okay, when I say prerequisite, you need not have complete knowledge on this. Most of you have worked with some programming language, right? So you would already be aware of this. But if not, you can just go through what is that called? w3schools.com. Okay, it's a very simple site. It's called w3schools.com. Okay, in that you can search for each and every technology or each and every topic here. It doesn't take more than 10 minutes for each and every topic. Okay, so just go through these before the start of 4th session. Second session is about component architecture. Third one is about installation. So before the start of 4th session, if you are aware of what is an XML, what is a schema, at least at a high level, because as I told you, you never write a WSDL on your own, or you never write a SOAP request. No one can write it also. Even I cannot write it because it's so huge. Okay, but when it would be helpful is when there is an issue, it really gives you a very good explanation of where is it. So if you know these technologies, it would be helpful in debugging. Okay, not now, but later in the project, in your project days. But basically these are the things. So if you can just give a glance on these topics in W3 schools, that should be more than enough, and then we are good to go. Okay, so that's about it. That's all for today. So any questions you have?
Ravi, Pawan here.
Yeah, Pawan.
Actually, after completing this course, I will be able to take up the certification with the Oracle, right?
Yes, Oracle certification, yes, this course would be definitely very helpful for the certification, but just the course, you wouldn't be able to do the certification. Let me be honest. You need to give certain reading, like each and every topic. If you give some reading on it, then you will be good to do the certification. Because you need to know the concept at a core level, because certification, unfortunately, is not completely practical. It's more of theoretical for SOA. In fact, most of the Oracle certifications are theoretical, so you need to give some reading. So I'll give you the links topic wise, like what you need to learn. So that reading is basically for the certification and your future uh, projects. But as far as the practical knowledge is concerned, this course would be more than sufficient. Like you can just go into a SOA project and you will be able to understand and do everything. Obviously, you will be a little slow initially, but for a project practicality level, you will be 100% ready with the course. For certification, you need to do a little more reading.
And one more thing is like actually I'm pursuing my MS with Blixplan. So the only left part is like I have to do one project for them. So I thought of doing it in SOA.
Oh,
That's why
okay.
the main thing that I came to SOA here.
Okay.
So hope I would be able to do a project by myself after completing.
Yeah, you would be definitely able to do the project. Did you ask about the project or certification
No,
initially?
first thing is the certification.
Oh, okay,
The
okay.
other one
I
is
heard it right. Yes. Project, you will be definitely able to do it. So end of the course, I would give you a scenario, a project scenario, and I will show you the example like after a week, like after I give, like you do your homework, and after a week we can have a session and I can show you like how you have implemented or how it is to be implemented, because there are so many ways to do it. So uh, at that point, like you will really know how to do, or we can actually have a session. I can show you. I won't share the code, but I can show you a real world example so that you will have a definite idea.
uh, and for the software things like anyway, I think that we can able to download it from the Oracle site and we can install it on our own machines, right?
Yes, everything is absolutely free. You just have to have an Oracle account. So third session will basically deal with all the installation in your local machine. So you have virtual machine to do, or you can do all the installation by yourself. So I'll tell you both the approaches. You can follow whatever you like.
And one more thing is like, is that OSP is part of 12C SOA suite or it's going to be the other part?
Yes, OSP is part of Oracle 12c. They have bundled it together, but this course is completely on the Oracle SOA concepts. Okay, so
Oh,
if I tell you more specifically, like whatever SOA 11G is, so it covers all those concepts. They have brought in Oracle OSB into 12c, but I wouldn't touch OSB. I would deal with all the SOA concepts on 12c because OSB is
oh,
something different.
oh.
Yeah, Ravi, Kumar here.
Yeah, Kumar.
Quick thing, this course does covers this business process execution language, right? In
Yes,
depth, right?
covers. Yes, in depth. I think you have joined little late, so actually I can take you. I can take you through the list of topics. I wanted to take you through it tomorrow, but BPEL is one of the major things that we deal with it, because in most of the projects, BPEL is the main thing that you have. So this is BPEL, this is BPEL, this is BPEL, and then this is BPEL. Literally everything is BPEL. I mean, you have different concepts, but all these are dealt with BPEL. So
Okay, okay.
yeah. That's what, like whatever you require for the real world. I mean, since I've been doing this stuff since 10 years, so I know what it is, what to learn and what not to. So
Okay, okay, okay.
most
Ravi, a quick
technical
thing,
ones,
one more question. One
yep.
more question. I have sent an email to you about my availability. If you could respond back to that, it would be great. Otherwise, I will call you in your mobile number later.
Okay, sure. I haven't seen the email. I'll just
Okay.
respond to that. I think you
Yeah,
sent
yeah. After this.
it. Yeah. Okay. Okay.
Yeah,
Ravi, on the same note, so in India, right, we'll be having our office timings in the morning. So if you
Correct.
could a little bit adjust for 15 minutes early, it will be really helpful for me.
Yep. That all depends on the folks on PST time zone. So once the batch is decided, so we will have to see I think who all are on PST. I think Naga is on PST. So if Naga can actually come down by 15 minutes to half an hour, we can all move it by half an hour. Yeah.
Yeah, sure. I can do it.
Yeah, sure. So once the batch is decided, like tomorrow would be the second demo session, right? So this would be answer to your question also, Kumar. I just saw the mail. So after the 2 sessions, we'll have a 2-day break, so that because we wanted to take care of all the other things, right? So once everything is done and once we are decided, we will take the most appropriate time for everyone. Okay, and then we can start the course either from Friday or from Monday. And anyways, you will be provided with all the sessions, so all the recordings. So even if you miss one class, like you're always good, and you can ask the questions anytime. And then if most of the people are not available on a particular day, then it's not hard and fast rule. So we can actually skip the session, or we can postpone the session also. So on time wise, I'm really flexible. I'm on EST, so 10 o'clock, either it is 9:30 or 10:30, I'm good. It all depends on the folks in PST and folks in India. Okay. Any more questions? So, Tommy, I hope that I have answered all the questions. So let me go through it. Yes, we have answered. And then yes. Okay, sure. Okay, if you don't have any questions, then let's stop for the day. I'll send you the recording. So I will upload the recording to Google Drive and share you the link. You can just download it in your system. Only thing I would like to ask you is, please don't share it to anyone, because this is kind of a paid course, right? So let's not share it to anyone. Let's keep it for ourselves. And then Tommy asked for the lab work. So we would be doing a practical example for each and every component on Oracle SOA. So lab work in the sense, like we would be doing the exercise right here in the course, right? So you would actually, ideal thing is you have to do it after the end of the course, so that you are really learning what you wanted to. And then after end of the major topics, like after we are done till people, or after we are done till human tasks, I can actually give you a scenario, so that you can try to implement the scenario, which will help you to practically implement, what will help you the practical knowledge on the SOA. And then I will share you the links of different material. So let me be honest, I don't have any proprietary material. I haven't written any material as such, but I will share you the links, not to the books, but specific to the topics. So for adapters, the best resource that you have is Oracle documentation. So I'll share you the exact documentation. There are 3: implementation guide, developer guide, and there's another guide, but I'll share you the exact link, what to see. For mediators, it's different. For BPL, it's different. So that way, you can actually, you go through the same books, but topic-wise. So if everyone is good, then we can stop the session. Oh, I think it's 1.5 hours, right? Okay. But anyways, it would usually be 1 hour. Thank you. Usually,
Okay, Ravi. Thank you very much for it.
1 hour. If it's more than 1 hour, I'll let you know like much ahead, so that you can